Hi, so this is the second question of question 6 for semester 5. It says find the unique solution of the system of linear equations below using the LU decomposition method. Now I have already done this question in a different video using the Gaussian method. The LU decomposition is a bit longer to do. So this is the question here. We're given these three equations, x1 plus 2x2 minus x3 equals 2, 2x1 plus 5x2 minus x3 equals 10, and 3x1 minus x2 minus x3 equals 7. Then I rewrote it already to save time in the form of ax equals b as matrices. So a is the coefficients 1, 2, minus 3, 2, 5, minus 1, 3, minus 1, minus 1. And x is just the x values, x1, x2, x3, x variables, sorry, equals our solutions to these equations 2, 10, and 7 are matrix B. Okay, now so the idea behind this here is that AX equals B is our matrices, but we're going to split the matrix A into its lower triangular matrix times its upper triangular matrix times X equal B. So this is where most of the work has gone to, is to split A into two matrices. One is lower triangle, means that the upper triangle is 0, and then the upper triangular matrix means that the lower triangle of that is 0, times X equals B. And then the step we do is step 1 to this is we multiply U times X. And we get a value, just say we call that a little matrix Y, a column matrix Y. And then step 2 is we multiply L, which is by UX. So now we're calling it Y for now. We multiply L by Y, and that gives us B. And from that, we can find solutions. So that's step 2. And then we can get solutions. Get solutions for X easily from that using substitution. Now, that means we're going to have to figure out what the lower matrix and the upper triangular matrix are. So the lower matrix it's a 3 by 3 matrix, the same as this, and down the diagonal we will have 1, 1, and 1. And the upper part of the matrix is going to be 0, 0, and 0. Now, the way this goes is this here is row 1, column 1. Now, this position is row 1, column 2. Now, this position is row 1, column 3. Here we're at row 2, column 1. So that's called L21. Okay. Then when we go down to the next row, this is going to be row 3. So it's 3, column 1. And here we're still in row 3, so it's L for lower triangular matrix, 3 because it's row 3, but now it's in column 2, so it's 3, 2. And that is the lower triangular matrix with the L's instead of values. We have to find these values. And then the upper triangular matrix is going to be, it will have zeros down below. It'll have 0 here, 0 here, and 0 here. But this first value, we'll call it U for upper, and it's row 1, column 1. And then here we have the upper triangular matrix. It's still row 1, but it's column 2. And then the third value here is U, upper value, upper triangular matrix. It's row 1, and it's column 3. I'm not going to do these lines. There, that'll have to do. Then in here, that is going to be, that would have been at 0, but it would have been row 2, column 1. And now this here is going to be U, row 2, column 2. This one is going to be U for upper triangular matrix, row 2, column 3. And then this would have been row 1, column, row 3, column 1, 3, 1. The subscript here would have been row 3, so it would have been 3, column 2, 3, 2. And here, our last one, it would be upper triangular matrix, and it's row 3, so it's 3, and it's column 3, so it's 3. And what we have to do is multiply these out. So, and then But they are equal to, when you multiply them out, they're equal to A. So I might just squeeze A in here. 1, 2, minus 3. When they're multiplied out, 2, 5, minus 1, and 3, minus 1, minus 1. So out of this, what I'm doing is I'm working on finding out what L and U are at this line here of our method. So I'll pan up a bit now because I'm going to multiply out these matrices, and that is work. Okay, so I'm going to multiply the row by this column here. So it's going to be 1 times U1, 1. And I'm going to write it all out, even the unnecessary parts. 1 times U1, 1 plus this 0 times this 0, which is 0, plus. So it's the top row by the first column, and the last position here is 0 by 0. And that's all one element in the matrix. Now I'm going to multiply the first row by the second column, and that's going to be here. So the first row by the second column is going to be 1 times U1, 2 plus 0 times U2, 2, which is 0, plus 0 times 0, 0. And that's the second element. So the first element we have here will equal 1. The second element will equal 2. And now the third element is going to be the first row by the third column. So it's 1 times U11, or sorry, U13, plus 0 times U23, plus 0 times U33. Right, that's the first row done. So now the second row is this second row here by this first column. So it's L21 times U11. L21 times U11 plus 1 times nothing. That, so we don't think it's 10. 1 times nothing plus nothing times nothing, which is nothing. So then it's the second row by the second column. So it's L21. L21 times U12 plus, so this row by this column, so it's going to be 1 times U22. Okay, and then the second row, oh, still at second row, 0 by 0 plus 0 by 0. And now we're going to the third element in the second row, so it's going to be the second row by the third column. So it's going to be L21 by U13. Plus, we did that. Now we're doing 1 times U23 plus 0 times U33. Okay, which is going to be 0. And now we're at the last row. So it's the last row times the first column. So we'll have L31 times U11 plus L32 times 0 plus 1 times 0. That 1 times that 0. And now we're in the middle element, so it's going to be L31 times U12 times U12. Plus L32 times U22 plus 1 times 0. And finally, we're at the last, very last element, which will go into row 3, column 3. So we have to multiply row 3 here by column 3 here. So it's L31 times U13 plus L32 times U23 plus 1 times U33. Now, we have multiplied the lower matrix, the lower triangular matrix, by the upper triangular matrix, and this is what we get. But these values correspond to the values from the matrix A, so I'll put them in on a different color. So this corresponds to 1. This must equal 2. This must equal minus 3. I'm taking these values from this matrix here, the matrix A. And the next row, this must be 2. This must be 5. This must all add up to minus 1. And here, these must be 3, minus 1, and minus 1. And we can use these now as equations, because basically, if you look at this, U11 must equal 1, because the other values are 0. So I can write U11 equals 1. U11 is this. And as these two values here are 0, I can say U12 equals 2. And the same for the third one. These are both 0, so U13 is minus 3. Right. And then we go to so that's the first row sorted, right? So then we go to the second row. You need space for this. So then, if you look at the second row, L21 plus U11 times U11 plus nothing must equal 2. So if I just write it here, L21 times U11 equals 2. That 2, which came from 2 here on the matrix A. But we know that U11 equals 1. That was the first thing here that we got. U11 equals 1. So then that means L21 times 1 equals 2, which basically L21 equals 2. L21 equals 2. So, right? So now we're going to do this one here. So we have L21 times U12 plus U22, that's this middle element, plus nothing equals 5. But what have we got here? We know L21 is 2, and we know U12 is 2 times 2 plus U22 equals 5. So 4 plus U22 equals 5, so U22 equals 5 minus 4. U22 equals 1. 2 equals 1. Okay. Right, so that's done. So now we're at this equation here. I'll scroll up a bit. Yeah. People only do this when they're told to do it. If you're not asked to do it this way, you would generally use Gaussian elimination. But we've done this one, so now we're at this long one where we have L21, which we know is equal to 2, but I write out the equation. L21 times U13 plus U23, right, plus nothing. Oops, I shouldn't have scored that, but anyway, that's nothing, equals minus 1. Now, what values do we have here? L21, we've already figured that out as 2. U13 is minus 3. U23 we don't have, equals minus 1. So U23 is equal to, that's minus 1 there. This is minus 6. When it becomes over, it becomes a plus 6, which means U23 equals 5. Okay. Then where are we now? We've done this equation. We're at this equation here. So we have L31, U11, plus nothing else. That's 0, and that's 0, and that must equal 3. And we know U11 equals 1. So that means L31 equals 3. Let me just put these inside little boxes so I can find them again later. Okay, right, I'm going to squeeze this equation in here just so you can get it all on the one screen. So this equation now we're at here is this one that equals -1. So we have L31 times U12 plus L32 times U22 plus nothing equals -1. L31, we've got that as 3. U12 is at the beginning, was equal to 2 times 2 plus L32 times U22. We don't have L32, that's the one we need to find, L32. But we know U22 is equal to 1, so 1 times L32 is just 1, equals -1. So that's 6, so we have L32 equals -1 minus 6 when we bring it across. L32 equals -7. Nearly there. The only thing we have to find now is L33, and we'll use this equation here. So I'll just put it in here. L31 times U13 plus L32 times U23 plus U33 equals -1. L31 is equal to 3. U13 is equal to -3 plus L32 is -7, which then I make that -7. U23 is 5 times 5 plus U33 equals -1. So that is -9 minus 35 plus U33 equals -1. That's -44. Okay, scroll down a little bit. Whoops. Just to get this in. So that was -44 plus U33 equals -1. U33 is equal to -1 plus 44, which is 43. Now you rewrite out all the matrices, right? So you rewrite out the lower triangular matrix using the values we have. Okay, so I'll try black for change, right? I still don't have room, but I'll start the matrix. So we know the lower triangular matrix has 1 down the diagonals, 0, 0, and 0. Here's the 1. And then this value here is going to be, it's in the second row, first column, so it's L21. And for L21, we got, just about see it there, 2. L21 is 2, right? So where's this cursor? 2. Then L31 is 3. That's it there. L31 is 3. And then we're looking for L32. L32 is -7. So this is the L, or the lower triangular matrix, right? The upper triangular matrix, U, is equal to U11, which is 1, U12, which is 2, and U13 is -3, basically the same as the A matrix. Then we have to get a 0 here, 0 here, and 0 here. We have them. So now we're looking for this value, which is in the second row, second column, U22, which is 1, there. Then the next one is second row, third column, U23, which is 5, there. And the last one we need is U33, which is 43. Okay, so that's L and U. And then if you wanted to say times X1, x2 and x3, it equals to what we had at the beginning. So for B, which was 2, 10, and 7. 2, 10, and 7. So now, instead of having one matrix A, we have split it into two matrices, the lower triangular matrix and the upper triangular matrix. And that's what we're going to work with now. So now just recall what we have done so far. So recall. We had the matrix A times the matrix X equals B. We split the matrix A into the lower and the upper triangular matrices times X equals B. All right, and that's it there. The lower matrix times the upper triangular matrix times X equals B. Now, UX, we're going to say, well, we can multiply out UX and we'll call that Y, which means then that L times Y equals B. The lower triangular matrix times Y equals B. So that's U multiplied by X there. Now, this is where we start here. So this is where the question changes. Now we have the lower and the upper triangular matrices. The question can start going quicker now. And we start here, Ly equals B. So we're going to let Y equal Y1, Y2, Y3. So here we have the lower triangular matrix 1, 0, 0, 2, 1, 0, 3 minus 7, multiplied by Y, which is going to be called Y1, Y2, Y3. And that's U of X, but we'll figure that out later. We're working backwards. Equals B, which is 2, 10, and 7. So remember, this is a 3 by 1 matrix. And this is a 1 by 3 matrix. No. This is a 3 by 3 matrix, sorry. Right, well, I just score that out. Write that again. This is a 3 by 3 matrix. And this is 3 rows by 1 column, a 3 by 1 matrix. And we will end up with a 3 by 1 matrix, the two outside ones. Right? So that means if we multiply this now, we're going to have the top row by the one and only column. So it's going to be 1y1 plus 0 plus 0 plus 0 plus 0 equals 2. And then 2y1 plus 1y2 equals 10 plus 0y3 if you want equals 10. And then the third row by this column should equal 7. So we have 3y1 minus 7y2 plus y3 equals 7. So when we sort these out, we know now from this one here, we know that y1 equals 2. Okay, and when we put that in, we have 2 from this equation here. 2 times y1, 2 2's, plus y2 equals 10. That implies y2 equals 10 minus 4, which is 6. And then from the third equation, we have 3y1. That's going to be 3 times 2, which is y1, minus 7y2, which is 7 times 6, plus y3 equals 7. And when I sort that out, that's 6 minus 42 plus y3 equals 7. And that goes to 6 minus 42 minus 36 plus y3 equals 7. So y3 equals 7 plus 36, which is 43, which is cropped up before. So, okay, so our values are y2, or y1 is 2. So the y matrix, I can write it here, is 2, 6, and 43. All right. 2, 6, and 43. So we have used L, the lower triangular matrix, times y equals b, and now that we have values for y, y1 is 2, y2 is 6, and y3 is 43, we can use U, the upper triangular matrix, times x equals y. So let's just pan down, and the upper triangular matrix is 1, 2, minus 3. That's the upper triangular matrix there. And I'll sort that out now. So we're at the upper triangular matrix times x equals y. And the upper triangular matrix is 1, 2, minus 3, 0, 1, 5, 0, 0, 43, multiplied by x, which is x1, x2, x3, is equal to y, which we just got, which was 2, 6, and 43. Again, it's a 3 by 3 matrix multiplied by 3 rows by 1 column, 3 by 1 matrix, and when we multiply these out, we'd get a 3 by 1 matrix. So now let's multiply them out. 1x1, x1. Oh no, don't do it that way. Work from the bottom. It's easier to work from the bottom because of that. Let's just rub this out. Sorry about that. Look, 43 x3 is 43. Therefore, x3 is 1. Now we work backwards. We do the second row by this. We'll have 0 times x1 plus 1 times x2 plus 5 times x3 equals, this is going to be 6 because we're working the second row times the column will be 6. We already have a value for x3 of 1, so we can put that in for x3. We're not going to find x1 at 0, so we have x2 plus 5 ones, x3 is 1, equals 6. So x2 equals 6 minus 5, which is 1. Okay, so x2 is 1, x3 is 1. Now we'll go, so we're working backwards. We go back to the top row now, so now we can say 1x1 plus 2x2 minus 3x3 equals 2, the top value. The value for x1 is 1. No, the value for x1 is unknown. The value for x2 is 1, so that's 2 ones. Minus 3 times the value of x3 is 1 equals 2. So that's x minus 1 equals 2. This is x1, little one here, little one here. x1 equals 3. So our solution, our answer is x1 is 3, x2 equals 1, and x3 equals 1. And it can be written as a little vector 3, 1, 1 if you want, or a column matrix. That's that done. Thank you.